Hello, here is the science for today, and before we begin, I have to say that this is going to be a very strange lesson to do at home. As I've said in the blog, you're going to need a couple of things. You're going to need a scale to measure things with, and you'll need some stuff to write down with, and ideally you'll have a bouncy ball as well that you'll be able to do with this one. If you don't have these things, I've linked in the blog a YouTube video you can look at, and the reason is we're going to measure the mass of something so that you'll learn the difference between weight and mass. But some of the things involving measuring Newton meters we won't be able to do. So without further ado, let's get into it. What we're going to do today is think about the effect that gravity has on objects. Seems obvious, I know, and learn about how the first theory of gravity was developed. We're going to be using some sheets on purple mesh, so make sure you have a look at them if you haven't already. You can explain the effect of gravity on unsupported objects, learn about Isaac Newton's role in developing a theory of gravity, an idea about how it works, and ideally we're going to measure some things. We're not exactly going to measure the force of gravity, we aren't, we're going to weigh things, but it's a bit different, as I'll explain when we get there. So first things first, it says here, watch your teacher let go of a bouncy ball. You obviously can't do that. The video I've got on YouTube, someone does drop it. What would be better is if you can drop your bouncy ball now and see what does it do. Now these children, who we're going to put up here, are discussing why the bouncy ball falls down rather than falling up, sideways, or staying still. Which do you agree with? The first girl says there's no air resistance acting on the ball, so it can go straight down. The second boy says the ball is falling downwards because gravity is pulling it down. The third girl says the ground exerts a force on the ball, so the ball is magnetically attracted to the ground. And the fourth boy here says the bouncy ball falls down because it's heavy. If it were lighter, it would float away. What do you think is right? Well, of course, gravity pulls the bouncy ball downwards, so it falls down. This is correct. Gravity is the force that means that all objects are pulled towards the centre of the Earth. All the objects exert a gravitational pull, but only really big ones, only ones with a lot of mass, are strong enough to feel. The Earth is a huge object, and we're very close to it. That's why it has an extremely high mass. It's other huge objects, like the Sun, obviously, its gravity pulls us in orbit, and the Moon, which orbits around us, but also the gravity of the Moon affects the tides. Something that has a small mass, say for example your pencil, although it has a very tiny amount of gravity, not enough to be detected. But all things have gravity, even you. Now this, the picture from the guy at the beginning, he is Isaac Newton. Do you know why he's pictured next to an apple tree? If you've read the fact sheet, you'll be ahead of the game here, because he famously developed the theory of gravity when he saw an apple fall to the ground from an apple tree. Now is the time when I want you to pause the video and find your fact sheet here to read it about him, and then do the questions on the gravity and activity sheet. Now, weight and mass, often when people say them, they use the same thing. When you ask someone how much they weigh, which might be a bit of a rude question, but you know what I mean, they'll often give you an amount in kilograms. But this is actually the measure of the stuff inside an object. That's what's measured in kilograms. Weight, specifically, is the strength of gravity actually acting on an object, and that is measured in newtons, as all forces are. The weight of the object is caused by gravity pulling it down, and objects with more mass have a greater weight, which means that the force of gravity pulls them down more strongly. Now, an object's mass does not change even if it goes to a place with a weaker gravity, like the Moon, which obviously has less gravity. But the weight can change. That is why when astronauts go to Earth, there's not less of the astronauts, but they can jump around much higher because there's much less gravity on the Moon. They're further away from Earth, so they're not affected as strongly about it. Now, Jupiter is a much, much bigger planet than Earth, and it has a stronger gravitational pull, so that even though an object would have the same mass on Jupiter as anywhere else, it would weigh much more. The gravity would pull it down strongly. You can imagine this if you were standing on Jupiter, not that obviously you could do this because of all the problems you'd have with space travel and so forth, but if you try to jump up, you'd really, really struggle, whereas if you jump up on Earth, you can do it. And there are some places like on the Moon, if you jumped, you'd go really, really high up. So remember, these are the key facts. Mass is how much matter, or stuff, which is inside the object, measured in kilograms, whereas weight is how strongly gravity is pulling it down, and this is measured in newtons. So here's what I want you to do, and this is where you're going to need some scales. I would like you to measure, it says here the weight and the mass of different objects, and normally you'd see this picture of a Newton meter. If we're able to be in class, I'd be able to give you Newton meters and we could try it by putting things in a bag. However, you cannot do that. So what I would like you to do is find some objects around your house. The more unusual, the better, and try and weigh them. If you're using bathroom scales, which are designed to weigh people, then you could do things like obviously weighing yourself, but you'll have to weigh quite heavy things to get it to detect it. If you have kitchen scales, which are usually made to measure things up to 1, 2, maybe 3 kilograms, then you'll want to get smaller things like cups, glasses, plates, pencils, things like that. Obviously be sensible about what you put on the scales. Please don't break them just for the sake of a science experiment. These are some facts you need to know. Since we can't work out the weight because we're not using a Newton-meter, I just want you to do the maths today. And what we're going to do is hopefully when we come back, we'll be able to look at some of these things and use a Newton-meter to check it. Sorry, I've gone backwards. There is a sheet here. Now this sheet is not going to work perfectly because again, we can't measure the weight. So what I would like you to do is find the table here, and I want you to create your own table where you have an object in one column, the mass in the other one, and leave space for a weight column, but don't fill it in now. I know this is quite complicated, so please do let me know how you get on and email me if you have any questions, as I know not everyone's going to have the same stuff. Good luck, and let me know how you get on.